Alright guys, so year 12, today we're starting a new topic. The new topic that we're starting is called annuities. So it's the last topic in financial mathematics that we've got to come across for our subject. So today we're going to quickly talk about what is an annuity and how is it different to compound interest. We're going to recognize the key features from a table of what we call future values of an annuity and how to use that, and then obviously use that table to answer questions based on annuities. So to start off with, I'm just going to open up this compound interest file, and you can see here, I'll just move myself a little bit out of the way here. You can see here I've got two tables, and the tables I've got is got a compound interest table, and I've got a table what happens with an annuity. Now, compound interest, when we invest money in a bank account at compound interest, we just put the money in the bank account and we just walk away from it. So what I've got here, you can see I've got $20,000 invested at 8.2% per annum. It's compounding quarterly, so it's compounding every 4 periods. And you can see I've invested $20,000. So in that first quarter, $20,000 has earned $410. So it's grown. So then remember, with compound interest, it goes, hey, you've gotten bigger. What have you gotten bigger to? Here it is. Let's calculate the interest for this quarter and add it in. And if I go through this table, I can pull these down, and you can see through my table, you can see it starts to grow. And you can see that in every period that we're going, so when we're up here at this 10 periods, that's 10 quarters worth of investment. It's now earning $492 in that quarter. Right at the beginning, it was only earning $410. And you can see after 20 quarters or 20 investment periods, our account has now grown to $30,000. But we've done nothing to it. We've literally put $20,000 in, we walked away. 20 quarters later, it's now worth $30,000. And at the end of the day, that's not really how we tend to use finances. Most of the time, we tend to be adding money to our savings accounts. And that's where annuities come in. Annuity is compound interest, but the next level. And it takes into consideration that we make regular repayments or regular repayments or adding money to our account. So here I'm going to look at what happens if we start off with $20,000 in the bank account, but then over those quarters, we add $200 at the end of every quarter. So I'm going to put $200 in there. Now over here, you can see started off with $20,000 in that quarter. Same thing again. I've earned $410 interest. But now the difference is at the end of that quarter, I've put an extra $200 in that bank account. So it's grown. Okay. And what we can see as we're going through, we can start to see this is now slightly different. This is now $20,610, whereas that was $20,400 because I've got that extra payment in. And if we populate this table, so just give me a second here, you can see now I've filled that table. And then if we have a look at the difference here that we've earned, we've gone $30,000 is here, and we've got $34,000 here. Now, what we can see here is, between these two have grown. This one's grown by $4,000. $4,895 more than this account has, because I've also been adding regular payments, and it's something we'd expect. But if we have a look here, over all this, if I add all this together, I don't know why I added all this together, but because that's silly. Anyway, we can see that the difference between these two amounts is about $4,000, $4,894. So what we're going to actually do here is the difference. I'm just going to say the difference is this minus this. You can see there's a difference of $4,883.74 at the end of that period. Now, if we think about it, I've put an extra $4,000 in over that time. But just because I've put that extra $4,000 in, I've generated an extra $883 worth of interest. So just summarizing quickly here, compound interest, put the money in the bank, don't touch it, don't do anything to it, walk away, and it looks at the end of each period and goes, oh, you've got more money, let's add some interest. Oh, you've got more money, let's add interest to that. An annuities table, well, it works slightly differently. An annuity is, well, you've got some money in the bank. I'm going to give you interest on that money, but I'm also going to accept a payment from you. You're going to pay extra money in there, and the account grows that way. Now, some of the more astute students out there may have noticed that this kind of looks a little bit similar. If we think back to reducing balance home loans, you'd have the opening balance of the loan, you'd have the interest, you'd add the balance and the interest together, and then you would take away a repayment. If I change this, let's say we're going to take away $500 a month. What you can see here is $20,000. The bank charges $410 worth of interest, but then we take away $500. So now our balance is $19,910. And as you can see, as this is going down, our balance is slowly reducing and our interest is getting less and less. That was modeling a home loan repayment table. So home loan repayment tables work like this idea of an annuity, where we can either think about putting money into the account every single time, or we can also think about taking money away from the account, whatever we want. So let's go back to my iPad and have a look at that. So if I bring back my iPad, I'll close this. That's what we're looking for here. My iPad. All right. So we've looked at what the difference, compound interest and annuity. And an annuity is you're making that extra regular repayment to it. So what is a future values table? Well, this is a future values table. And running through the details, future value table, it's the future value of, most times, it's $1. So the future value of $1. What that means is that someone has done all the hard financial calculations for us. And if we invested $1 into a bank account, that was our regular payment into the bank account. Remember in that table, that compound interest table we looked at, in the annuity we looked at putting a regular payment of $400 in, or taking away $500. This is what this $1 would, if our investment into this was, we'd pay $1 at the end of each investment period. This table tells us what it will grow to. So it grows to. So picking up something, just let's go here. If I invested $1 if I put $1 in a bank account regularly at 6%, and I invested it for 5 periods. Now I might put $1 in at the end of every year, and I get 6% per year. I might put $1 in at the end of every month, and I get 6% per month. or $1 at the end of every week, and I get 6% per week, whatever the period is, this value here, where those two rows meet, is what my $1 will grow to. $1 for 5 periods, whatever how length of time that is, at 6% grows to $5.6371. And the beauty about that being $1 is I can make $1 any value I want. I can make 1 into 20 by multiplying it by 20. So if I invested $20 per period, I'd find what $1 is worth and then just times it by 20 to figure out, well, what would it be, the result be, if I ended up investing it for 20 periods. So what we've got in summary, to use this table, the first thing you need to do is determine the time period and the rate of interest. This is where it works like compound interest. We need to think about, are we playing with months? Are we playing with quarters? What are we doing? Then we just read the table like we just did. Find where we intersect, and then we're just going to multiply the number, like I did previously, with how much we invested. So let's go look through a couple of examples here. So, if $400 invested into an account at the end of every year for 2 years, this is the part that gives it away that it's an annuity, that something's invested at the end of the year. So at the end of the year for 2 years at 3% per annum, what would be its future value? So we need to think about this. It's $400 per year. This is our period. That's how often we're making payments. So everything needs to be in years. Well, that's in years, and per annum, that's an annual too. So now what we do is we go to our table and we're looking at the 2 years row, 3% row, and the value that we're using is that 2.0300. So the value from our table is 2.0300. So our future value, well, how much did I invest? I invested 400 lots of that 2.0300, and we evaluate that on a calculator, remembering we round our answer to 2 decimal places, and we're going to get, helps if I had my calculator, so 2.0300, 40012, 8, there's 1, 2, 3, 4, 2, $812. So our investment is going to grow to $812 after that 2 years. Right? If you think, if we've put $400 per year, so the interest part is 400, the interest is everything that we earned minus our repayments. So on this investment, we've only earned $12 interest, but it's $12 we haven't had to work for. All right, part 2 here. After 5 years of making regular payments into account at the end of each year, there it says at the end of each year, so everything needs to be in years, the investment grew to, so this is saying it grew to, so that is a future value. So we know that something grew to this. If it was invested at 4% per annum, what was the value of that regular payment, that contribution? Well, so it's yearly, so everything needs to be in years, and our future value we've been given. So now we go back to our table, and for our table now, we want the 4% column and we want the 5 years column, so we want this number 5.4163. And our contribution here, it's going to be, remember we would have multiplied 5 point, what did we say, it was 5.4163. We would have multiplied that by something to get our future value. We would multiply that by our contribution. So our contribution is our future value divided by our table value. And when we evaluate that, we get $500. So this person paid $500 into that bank account at the end of every year. All right, 4 more examples to go. Stick with me, get this done, and then you'll get off onto some work. So looking at these questions, but then slightly playing around with them slightly differently. So A, what is the future value of an investment if of $300 per month? So here we go, we've got a per month. So now we need to make sure that everything we're dealing with is in months. For 3 months at 25% per annum compounded monthly. So because everything, like we said, is in months, our number of periods we invested in, it's in months, happy days. But our interest rate, 24%, that's a per annum. So we need to divide that by 12 to get it to monthly. So it becomes 2% per month. Now that we've got everything in months, we go to the table and we're looking for the 2% with the 3 periods. So 2%, 3 periods, 3.060. So 3.060. So our future value, it's just going to be our regular contribution multiplied by that value from the table. And what we end up there with that question, we'll get a future value of $918. Moving on to question B. Question B says, what is the future value of an investment when it is $15,000 per quarter? So quarters, we've got to think about for 1 year at 12% per annum compounded quarterly. So quarters, well, 1 year has 4 quarters in it, and 12% per annum, well, we need to divide that by 4. So that's 3% per quarter. So now we're going to go to the table and we're going to look for the 3% in the 4 periods column. So we want 4 periods, and we said it was 3%. So we want that number 4.184. So our future value here is our regular contribution multiplied by that value from the table. And when we do that, we get a value of $62,760. All right, moving along. Let's go blue. Find the payment or contribution. So now we've got to work in backwards because we don't know what our regular investment is. We've been told the contribution per period of annuity with a future value of $76,000, 3.5% per annum compounded annually for 4 years. So here we want everything to be in years. So if I go back and check, that's in years, that's in years, that's in years. I'm all happy. 3.5%, 4 years, let's go. So 3.5% for 4 years, 4.215. All right, so 4.215, and our contribution, remember that our future value, this number up here would have been C, our contribution multiplied by 4.215. So the contribution is then the reverse of that. Our contribution, 76,713 divided by 4.215, and we get a value of 18,200 per year. All right, because it was an annual investment, so $18,200 per year was invested into this annuity that it grew to. And then finally, question D, find the payment or contribution again of an annuity with a future value of $6,105 compounded biannually for 1 year. So straight away we can see biannually 1 year. They're not in the same units, so we're going to need to do something there. All right. So biannually just means twice a year. So it just means 2 times in a year. So if we've got 2 times a year, our 1 year, we're going to have to, well, that's 2 times. So it's 2 times in 1 year. Our percentage, we're going to need to divide by 2, so it's 3.5% per half of a year. All right, so we want to go back up to the table, look in the 2 periods column and the 3.5% column, and the 2 periods and 3.5% column is going to give us a value of 2.035. And again, this future value is the contribution multiplied by 2.035. So the contribution must be its reverse. So we have 6,105 divided by 2.035. We do the maths on that. We get $3,000 was invested for every half or twice a year into that bank account, and it grew to $6,105 over the year. And again, if we think about that, the interest on that is just going to be the total amount that's available in the bank account minus, well, how many payments did we put in? And we put 2 lots of 3,000. So that's going to leave us $105 worth of interest earned on that question there. All right. I hope that helps. Again, well, not again, but if none of it makes sense, shoot me an email. I'll try and clarify some things for you that way. Otherwise, from the Cambridge textbook, I'd like you to do exercise 7C and those questions there from exercise 7C, and I'll catch you guys later.